Okay, so in your hyperbolic functions, so notice that it's more likely similar to your trigonometric functions, but of course there are some terms here that is positive value compared to the trig functions, which is negative. So for example, the the integral of sine is negative cosine, diba? In your trig functions, but here in hyperbolic functions, it's most likely positive cosine. Okay, so again, the proper way to read this one is hyperbolic sine of u du is equivalent to hyperbolic cosine of u plus c. So if you imagine kapoy kay sigbasag hyperbolic, di ba? Hyperbolic sine, hyperbolic cosine. So if you want to kanang shortcut lang ang pagbasa, so just incorporate h in reading the different functions, diba? So let's say the trig functions is sine, cosine, tangent. So instead of that one, so just incorporate h. So shine na siya, shine. Then this one is cosine. This one is tangent, cotangent. This one is secant. Then we have cosecant. Okay, para dali siya one, diba? It's easier for us to um, say the hyperbolic function. So of course, kato siya is just a technique for us to be able to read the equation fast. But again, proper way of saying it is hyperbolic sine of u, hyperbolic cosine. So that's the equations. So that's how you read your hyperbolic functions. So looking at the 10 equations, so equations 1, 2, 7, 8, 9, and 10. So these are the equations that is, I think, familiar to you from your derivatives. So equations 3, 4, 5, 6. So equations 3 and 4. So the same technique as your trigonometric integrals. So you're going to use u sub here because your tangent and cotangent hyperbolic functions could be broken down into its components. So it could be hyperbolic sine all over hyperbolic cosine. Then the other one is cos over sin. Okay, so notice that the answers of your tangent and cotangent functions are in ln. So once you use the u sub, so you'll be reaching the basic formula, which is your ln formula. So that's integral of du all over u. So that's why we have ln as the answer for your tangent and cotangent. So I think this one is the same as your trigonometric integrals, but the other answer is, I think it's negative ln. So try verifying it later. Okay, so for your hyperbolic secant and hyperbolic cosecant, so this one is, I think, dili siya u sub. It could be u sub, but again, there are some of the books are using hyperbolic identities. So if you try to look at it up online later, okay, mura kuan siya. There are a few hyperbolic formulas compared to the trigonometric identities. So medyo kuan siya. So gamay ra siya. Yes, and then I don't think the examiner will provide you with problems that you need to utilize the hyperbolic identities. So marag more on the trig functions, I guess. So far sa akong experience. Okay? So next is the integral of your exponential function. So I'll just discuss this one together with the hyperbolic functions because this one is an easy integral also. So integral of e to the power of u du is equal to eu plus c. So again, this one is just the reverse of the other. So again, recalling in our derivatives, so derivative of e to the power of u is eu du, di ba? Nga ato ning integrate, balik ta sa e to the power of u. So naray plus c because again, if we try to derive c, so ma-zero ra gyapon siya, di ba? So derivative of constant is 0. Okay? So what if your base function is a constant? So a is a constant. So for example, 3 to the power of x, may nana nga mga example. So the answer to this one is this one. So if you want to verify a to the power of u over ln a plus c, the answer is this one. So we need to derive this one, diba? So deriving this one will, so we will use quotient rule man siguro to. So I think it's quotient nga rule. So katong v du minus u dv all over v squared. So mao siguro na, di ba? Because it's quotient. Okay? Or you can also utilize here the sub technique also. So you let u be something. Okay, so let's try to solve the 6 examples for us to appreciate the hyperbolic functions and the exponential functions integrals. Okay, so starting is we go to this one. So again, don't make your lives complicated, but of course we can just use the basic formulas. Okay, so using u sub, so ano u sub man, so again notice the exponent here. So we need to achieve a integral of u squared du ana. So obviously your u is equal to cosine x. So we know that the derivative of your cosine is sine x dx. So notice that your sine hx sine x dx is present in the equation. So of course we can replace it with u squared all over du. So we have u cubed all over 3 plus c. And the final answer is cosine cube of x all over 3 plus c. So easy as that one. So again, of course, you need to practice solving problems so that you'll be able to determine exactly the process that you need to do in your equations. Okay? So muna siya inyong button. So questions? So I think there's no question for example number 1 kay CC ora kayo, di ba? Okay, so next is your tangent, hyperbolic tangent squared x. So by formula, so of course, if you recall our trig function, so most likely your tangent hyperbolic function is most likely the same as your trig as yung derivative, di ba? So, ang derivative sa hyperbolic tangent is most likely the same as your trig function. So, more likely is that's secant h squared, di ba? But looking at your equation, wala man tayo secant h squared, di ba? Wala, we only have tangent. So, erasing. So, sige. So, meaning you cannot utilize this data here. So, if we try to think of it again, so since we have trigonometric identities, so we also have hyperbolic identities. So, to recall your hyperbolic identities, so let's try to list down first the one. So, this one are your trig Pythagorean theorem identities. So, secant squared. Then 1 plus cotangent squared theta is equal to cosecant squared theta. So this is your trig Pythagorean identities. So for your hyperbolic trig is most likely they are the same format but ang mga signages lang sub. So we have cosine squared theta minus sine squared theta is equal to 1. Then we have, so instead of plus here is we have minus. So 1 minus tangent squared theta is equal to secant squared theta. Then lastly is, again, instead of plus is we have minus 1 minus cotangent squared theta is equal to cosecant squared theta. So muna siya. Okay? So of course, looking at the two, so again, this one is hyperbolic. Wrong spelling. Hyperbolic. Okay. So we can utilize by replacing your tangent squared x with secant squared theta. So we need to properly kuan ang signages. So this one is, by isolating tangent, is we have 1 minus secant squared theta is equal to tangent squared theta. So 1 minus secant squared x dx. Okay? So we know that the integral of secant squared x is tangent, diba? So we have x, oops, sorry, so let's, okay, so the integral of the first term, so that's 1, is x. Then the integral of secant squared is tangent, diba? Hyperbolic tangent x plus c. So muna siya ang answer. Di ba mabura kayo, no? So it's super short if you know the hyperbolic identities. So if wala, so proceed to the next problem. So sa classroom pa ni setting, so hangad-hangad sa babaw sa class sa atop if na may formula dito, di ba? But karon online, so ay lang sad basta niya mo tanaw mo sa likod sa laptop kay na dito ang formula, or mo alt tab lang kalit para matanaw sa formula kay na dito ang symbol lab. So, depende na inyo sa inyong konsensya if... So, of course, ako, di ako mabalaka na og kuan mag-cheat mo basta sa ako ang part is ni kuan lang ta. Wata magkuwang sa pagtudlo. Okay? So, always be reminded that um, these subjects will go out in the board exam. So, part kaya po siya sa board exam. So, I suggest that earliest now is you try to learn the important stuffs for the board exam. So, mathematics, then the other major subjects included for the board exam. So, of course, there are some students, so probably that won't be taking the board exam. So, I have a few students before that was sila nag-board exam kay of course their family owns a business na. So, it won't matter to them if they are licensed or not. So depende yan ninyo sa inyong style, sa inyong kinabuhi. Basta, muna siya. Okay? So, we go to the third example. So, we have an exponential function as your integral. So, integral of 3 to the power of x squared minus 4 times x with respect to x. So, again, if you look at the base of the exponent, so that's a constant. So, most likely, we are looking at the integral of this function a to the power of u is equal to au all over ln a plus c. Okay. So of course, we declare the variables first. So 3 is your a parameter. Then the exponent is your u parameter. And that's x squared minus 4. So notice that we have a remaining term here, x dx. So most likely this one will represent du if ever the u sub technique is successful. So getting the derivative, so derivative of u is du, derivative of x squared is 2x minus 4. So minus 4 is a constant, that's 0 dx. So notice that x dx here is the same as the remaining term above. But since we have a coefficient of 2, so we need to isolate your x dx for us to be able to fully declare that x dx is this du function or du term. So du all over 2 is equal to x dx. So this one here is your x dx term. All right. So since everything has been replaced or can be substituted, so we have a to the power of u, then du all over 2. So factoring out 1/2, so that's au du. Okay, so the answer is 1/2 times a to the power of u ln a plus c. So you have 1/2. So bringing back the value of your a and u, that's 3 to the power of x squared minus 4 all over ln of 3 plus c. So final answer is 3 raised to x squared minus 4 all over 2 ln 3 plus c. So this is your final answer. Or you can rearrange the denominator since the coefficient of your log functions, natural log, common log, is the exponent of the term inside the log function. So you can also present it in this manner. So 3x squared minus 4 all over ln 3 squared, di ba? Ano na siya? Because again, the exponent here could be the coefficient of your log functions. So your answer could also be in this manner. So 3x squared all over ln of 9 plus c. So that's the other way to represent your answer, this one. Okay? So questions? Okay, so if one, huh? Huh? Hmm. Kani? Kani siya? Oh, full credit gyapon siya. But kani siya is you can also present it in this manner sad kani. Pero kani if mo ni siya answer kani siya, magdili siya full credit ani. Kaya ang 3x squared mo siya na simplify. Na so para di mo maghasol-hasol kani na lang na. Pwede ra sad na. Okay? So let's go to the fourth example. So looking at the given integrand, so we have a, the integral of a raised to tangent t all over cosecant, I mean cosine squared of t with respect to t. So notice that this one is exponential. So even though there's a trig function present, so we have an exponential function here. Okay. So again, since the method of integration is more of a trial and error method, so of course ato na i-try tanan. So here is we first utilize the formula for the exponential function because looking at your trig function cosine squared t, so if you try to recall the different formulas for your trig functions, there's no other process that kanang mo equate siya to an exponential function. So might as well that utilize first your exponential integrals. Okay, you're looking at the exponent. So the exponent of your exponential function is a trig function also. So maybe later, ang iyahang du is ma-eliminate niya ang other trig function present in the equation, di ba? So we have a to the power of u all over ln a plus c. So again, we declare the different functions. A is still a, and then your u parameter is your tangent of t. Okay, so getting the derivative, because we still have to replace dt and the remaining cosine squared t in the denominator. So derivative of tangent t is secant squared t dt. Okay, so notice that there's no secant in the given equation, but of course, since there's a cosine, so and then this one is a secant, so we can transform this one into its other format. So we have dt all over 1 over cosine squared t. Diba? Because 1 over cosine is secant. So since it's squared, so most likely this term here, so nakajackpot ta, diba? So we can replace every term in your equation. So tip for the sub-technique or for the u sub-technique, so every term in the equation, including the d parameter, dt, du, dx, will be replaced by the process of the sub technique. Okay, so as you can see, a is being replaced, the exponent is also being replaced, this term here is also being replaced, so there's nothing left for us to replace in the given integrand. Okay, so we have a to the power of u du. Diba? Marag dito na siya, diba? So the answer is a to the power of u all over ln of a plus c. So a tangent t all over ln of a plus c. So this one is the final answer. Okay, so questions? So I think there's no question. So let's proceed. So again, we have the integral of 6 times e to the power of 1 over x all over x squared with respect to x. So looking at the exponential equation, so we're looking at this format. So notice that in the remaining three transcendental functions, we are just following the format given to us. So e to the power of u du is equal to eu plus c. Okay, so let's try to eliminate first the constant. So we have e to the power of 1 over x all over x squared dx. So e is still e. Then the exponent is now the u parameter. Okay, so u is equal to 1 over x. So derivative of 1 over x. So again, this one can also be represented as its equivalent exponential term or format. So x to the power of negative 1. So getting its derivative, so we have negative 1 times x to the power of negative 2. So we have negative x raised to negative 2. Na, diba? Or in other format, so let's put the x here. So in other format, if we try to replace or if we try to bring back the x variable in the denominator, so that's 1 all over x squared dx. So notice that we have dx all over x squared here, but it's positive. So dividing by negative 1, so we have negative du is equivalent to 1 all over x squared dx. Okay, so this one is represented by this one. Okay, so we now have 6 integral of e to the power of u negative du. So I getting the negative outside the equation, so that's negative 6 eu du. Okay, so looking at the formula, so automatic na siya. So negative 6 times e raised to u plus c. So replace u back again in the equation. So that's negative 6 e raised to 1 over x plus c. So this is the final answer. Okay. Okay, so for the last example is we have the exponential function again. So we have e raised to u du. Okay, so our u parameter here is your sine x cosine x. Sine x cosine of x. So getting the derivative. So again, we have to use the product rule or the chain rule. So u dv plus v du. So sine x, derivative of sine x is u dv plus v du, di ba? So sine x yapon, di ba? Sakto? Plus cosine x, then derivative of sine x, sayop tayo. Derivative of cosine is negative sine x din na. This one is derivative of sine is cosine. Napali. Okay, so that's negative sine squared x plus cosine squared x. Or to rearrange it in such manner that the negative sign is on the second term, so we have cosine squared x minus sine squared x. So notice that the other term here to be replaced is cosine 2x dx. Okay, so this one is dx. So if you try to recall your trigonometric identities, so one of which is the double angle formula. So this one is double angle cosine. So for double angle cosine, that's cosine squared x minus sine squared x. So other format of which is 2 cosine squared x minus 1, 1 minus 2 sine squared x. So those are all equivalent to double angle cosine. So this one can be represented as double angle cosine dx. That's your du. Okay, so this one is this one. Okay, so we have the integral of e to the power of u du. So notice again that every term in the equation is being replaced. Of course, e is e gyapon, di ba? So answer is e to the power of u plus c. So final answer is e raised to sine x cosine x plus c. Okay. So questions for the last example. So I think there are no questions. So I think that's it for today.